Welcome to Learn Chemistry in 3 hours. In this first video, we are going to cover 3 contents. The first one, I'm going to share with you the structure of an atom, and then I will talk about electron configuration, and the last part is how chemical reaction take place. So let's start the first part, structure of an atom. This is really important for your understanding. Once you know the structure of an atom, you will understand how to position the electron, and you understand how chemical reaction take place. The first one, let's do the structure of an atom. Structure of an atom. Atom consists of nucleus in the center, and we have electron orbit around the nucleus, just like the sun in the center and planet orbit around the sun. The first subatomic particle we have in an atom is called neutron. Neutron is neutral in terms of charge. And then we have proton, which is positively charged. 2 of them reside in nucleus of an atom. So let me draw the neutron here. How many neutrons we have in an element, it's not what we are going to cover today. And we have proton in the nucleus as well. As you can see on my drawing, we have 3 protons inside the nucleus. So this is the nucleus. Perhaps I use different color to show this is the nucleus of an atom. And outside this ring actually is the orbit of electron. It doesn't really have the ring physically. I draw it so that you can see how electrons circulate around the nucleus. So that brings to the third element of the subatomic particle. We have, let me erase this and draw properly. So we have electron. Oh, why do you have all this drawing? Okay, we have electron. Electron is negatively charged, as we know. So one very important thing you need to bear in mind is that the number of protons of an element will never change. Will not change. What do I mean by this? For example, now this element has got 3 protons, then it is lithium. Lithium has got 3 protons. If you force to remove 1 proton from this nucleus, then it is not lithium anymore, it became helium. So number of protons of an element will not change. It is as good as representing the identity of that element. Just like our identification card number, this identification card number belongs to me. If you change 1 number, then it's not me anymore. So just bear in mind, number of proton will not change. Therefore, number of proton is not involved in chemical reaction. All right, so this is first part. Just remember, we have neutron, we have proton in the nucleus, and we have electrons circulate around the nucleus. That brings us to second part of the content, which is electron configuration. So I am going to clear my board and talk about electron configuration. Before I talk about electron configuration, let's talk about the number of protons. Like I mentioned earlier, each element has its certain number of protons, starting from proton number 1, we have element like hydrogen, who has 1 proton number. Let me write properly. Number of proton we have, starting from hydrogen, he has 1 proton. Normally, we will use a symbol to represent that element. So for hydrogen, the symbol is H. The second element who has 2 proton is helium. Like I mentioned earlier, the symbol has to be capital letter. So helium also starts from H, but H is being taken by hydrogen. What can we do? We can add 1 more letter to the symbol. So for helium, we have H, E. So the second alphabet has to be small letter. The third element who has 3 proton number is lithium. Again, the symbol is Li. The fourth element who has 4 proton in the nucleus is beryllium. Now, beryllium is not in the syllabus. It's purely for our discussion here. So you don't need to remember beryllium has got 4 proton. The fifth element is boron. Again, boron is not in the syllabus, so you can just ignore this. Okay, 1, 2, 3. I'm going to use lithium for our electron configuration discussion. Lithium, as mentioned just now, has 3 proton. That means it has 3 positive. Now, any element in a normal situation should be neutral in terms of charge. So if lithium has got 3 positive, that means it has 3 negative. It has 3 electrons. So let me draw the structure of an atom for lithium again. This time I will not draw neutron. Lithium has got 3 positive. That means it has got 3 negative. This electron circulate around the nucleus. It does not simply circulate, it has its own orbit. I'm going to draw the orbit of electron, the first orbit, second orbit. Before I draw the electron for lithium, one important information you need to bear in mind is that the maximum number of electrons that can reside in certain orbit is like this. The first orbit, maximum, it can accommodate 2 electrons. So this is the first orbit. The second orbit, maximum, it can accommodate 8 electrons. This is the second orbit. And the third orbit, maximum, it can accommodate 8 electrons. Since lithium has got 3 electrons, so the first 2 will put in the first orbit. So let me delete certain part and put the electron here. Leaving 1 electron, we can put it in the second orbit. So let me put it here, the second orbit. And therefore, the electron configuration for electron configuration for lithium, we write like this. The first orbit has got 2 electrons, and the second orbit has got 1 electron. So we put 2.1. This is the electron configuration for electron. One more terms you need to remember is that the outermost electron, we have a name for it. We call electron valence. And particularly, this electron is the one involved in chemical reaction. So electron valence is the electron at the outermost orbit. Okay, here is the electron configuration for lithium. For your practice purpose, can you write the electron configuration for fluorine? Fluorine, the symbol is F, and it has 9 protons. Since it has 9 protons, that means it has 9 electrons. With this information, you can pause the video and start writing the electron configuration for fluorine. All right, how's the electron configuration for fluorine? Let's recap about periodic table, the first 20 elements based on the number of protons. So I'm going to write here number of protons for the first element in the periodic table. This represents number of protons, and the first one is called hydrogen. The symbol is H. So how's the electron configuration look like? Since hydrogen has got 1 electron, and this 1 electron can be put in the first orbit. Therefore, the electron configuration for hydrogen is 1. The second element is helium. The symbol is He, capital H, small letter e. Since it has 2 protons, that means it has 2 electrons. And these 2 electrons can be put in the first orbit. Recall that first orbit maximum can accommodate 2 electrons. Therefore, the electron configuration for helium is 2. Proton number 3 is lithium. We have learned that lithium has 3 electrons and the electron configuration is 2.1. The fourth element is beryllium. For your practice purpose, we will put the electron configuration here. Just bear in mind it's not in your syllabus. So 4 electrons, first 2 goes into the first orbit, left 2 will go to the second orbit. The fifth element is boron, B. It has 5 electrons, 2 goes to the first orbit, and then left 3 to the second orbit. 6 is carbon. The symbol is capital C. It has 6 electrons, so 2 goes to the first orbit, left 4. So on and so forth. That means for the fifth element, we have nitrogen here, and the symbol is N2.5. Okay, let me draw a line to separate this. Continue with the 8th element. The 8th element who has 8 protons is oxygen. Oxygen, the symbol is a big O, 2.6. The 9th element is fluorine. The symbol is F, 2.7. Did you write the electron configuration for fluorine correctly? 2.7. The 10th element is neon. Neon is Ne because the N is already been taken by nitrogen, so add 1 more alphabet, 2.8. 11 is sodium. Sodium, the symbol is Na. 2, 11. Okay, this is interesting. 11, I don't have enough fingers. Okay, first 2 goes to the first orbit, left 9. Another 8 goes to the second orbit, maximum already, left one more, so goes to the third orbit. That means sodium has got 3 orbits, 2, 8, 1. So electron configuration tells you how many orbits that element have. For sodium, we have first orbit, second orbit, and the third orbit. Let's continue to magnesium. Magnesium, the symbol is Mg. So 12, again 2.8.2, and so on. So this is electron configuration for the first 12 elements. Interestingly, like I mentioned earlier, the electron that is responsible for chemical reaction is the electron valence, the electron at the outermost ring, which is this one. Why atom or element want to have chemical reaction? The purpose of having chemical reaction is to achieve stabilization. They want to be stable. That's why they have chemical reaction. Just like the fall in love analogy, people got married because they want to settle down, they want to build a family, they want to be stable. So having chemical reaction, the ultimate aim is to become stable. Let's look at how chemical reaction take place. Chemical reaction take place, the only subatomic particle involved is electron. So electron is responsible for chemical reaction. It is either being donated or received or shared. So 3 ways electron can involve in a chemical reaction: donate, receive, share. Let's look at hydrogen. Hydrogen has got 1 electron. It is also its electron valence. The maximum number of electrons that we can have in the first orbit is 2. So we have 2 electrons, then the orbit is stable. But now hydrogen has only got 1 electron and it is not stable. To achieve stable situation, hydrogen is a bit unique here. He can either donate this electron, then the whole orbit becomes 0 and is stable. Or he can receive 1 more electron. Now 2 electron is maximum, then that orbit is stable. Or he can also share with another hydrogen. So we have 2 hydrogen, 1 and another one that they share the electron. Now this hydrogen look like got 2 electrons, stable. Or this hydrogen here look like got 2 electrons and it is stable, so they can share. So hydrogen is a unique case. Next, let's look at helium. Helium has got 2 electrons at its orbit, 1, 2. It is stable. So therefore, helium will not get involved in any chemical reaction. So we say helium is like a saint. He doesn't get involved in chemical reaction. He doesn't fall in love. So we call him noble gas. So he has no chemical reaction. He is a saint. He is a noble gas because its state is in gas. All right. So this is helium. Next, let's move on to lithium. Lithium move on to the second orbit already. The first orbit is stable. He has 2 electrons. The second orbit has got 1 electron. Now let's think the second orbit maximum can accommodate how many electrons? We know it can accommodate 8. So for lithium to achieve stable, he has 1 electron now, short of 7. So can he ask somebody to donate 7 electrons to him? Is easier, or he throw away this one? If he throw away this one, left the inner ring who has 2 electrons, he achieved stabilization. So think, does he want to add 7 electrons easier, or minus 1 electron easier? Which one? Of course, throw away 1 electron, make him use lesser energy than attract 7 electrons. So for chemical reaction to take place, lithium will throw away this electron valence. Let's see. Now lithium has got 3 positive, left 2 negative. Which charge is more here? Look like more. Of course, the positive is more. Meaning to say, if lithium want to get involved in chemical reaction, he will temporarily become lithium 1 positive because he has 1 extra charge. Let's take a look at another example for your understanding. Beryllium. Beryllium has got 2 electron valence. The first orbit has got 2, second orbit has got 2 as well. Same thing, to achieve stabilization, he need to have 8 electrons at the orbit. Now he has 2. Throw away, attract 6 or throw away 2. Which one easier? Add 6 or minus 2? Again, it's easier to throw away 2. So to take place in chemical reaction, beryllium will become 2 positive because he has 4 protons compared to 2 electrons, so he has 2 extra positive charge. That's why he becomes 2 positive. One more example, boron 2.3. Again, the orbit needs to have 8 to become stable. Now he has 3. Throw away, attract 5 or throw away 3 is easier. Of course, throw away 3 is easier. Boron will become 3 positive because he has 5 positive compared to 2 electrons, so he has 3 extra positive charge. Let's move on to the next one. Carbon. Interestingly, he has 4 electron valence. He can attract 4 or throw away 4. Both is like equally needing the same amount of energy. So for now, let's put carbon aside. He is like in between of positive and negative. So we don't talk about carbon for now. It's a bit unique. Next, we look at nitrogen. Nitrogen has got 5 electron valence. To achieve stabilization, he need to be 8. So he attract 3 easier or throw away 5 easier. This time, 5, throw away 5 sounds like need more energy. He already have 5. 1, 2, 3, 4, 5. He only need to attract 3 more. 1, 2, 3. The inner ring got 2. So now, nitrogen will attract 3 more. That means he will become 3 minus. So imagine he has got 7 positive charge but 10 negative charge. So it's 3 extra. So that's why it becomes negative. Same things goes to oxygen. He will attract 2. That means he got 2 extra electron. And it becomes 2 minus. Next, go to fluorine. He will add 1 more electron. And therefore, he becomes 1 negative. So let's look at the periodic table again. If you think that I draw a bit too messy, perhaps you can clean up your own notes and pay attention to the charge. Okay, now lithium is, if he has to go through chemical reaction, he will become positively charged. Beryllium, positively charged. Boron, positively charged. Anything that is positively charged is metal. So these 3 elements are metal. Anything that is negatively charged are non-metal. Therefore, nitrogen, oxygen, and fluorine are non-metal. Positively charged have to attract negatively charged. This means lithium cannot have chemical reaction with beryllium. No, because positive cannot attract positive. Lithium can react with nitrogen. Oh, getting more and more drawing. Can have chemical reaction with oxygen, can have chemical reaction with fluorine. So once they attract each other, I'm using the example of lithium and fluorine. So when lithium attract with fluorine, 1 positive, 1 negative, attract each other, become neutral. Their respective atom is also stable already. Then they are stable. That's why they want to have chemical reaction. This is how chemical reaction takes place. In the next video, I'm going to talk about how to write chemical equation. So for your understanding and practice, can you write the ion for sodium and magnesium? We talk about this in video number 2. See you.